Welcome back everybody to another video lecture from Miss Semino. This video is the fourth video in the States of Matter series, and today we're going to be going ahead and talking about phase change. So a couple of the important objectives for this chapter is to identify the conditions necessary for sublimation. Remember that sublimation is where you're going from the solid phase to the gas phase without going through the liquid phase. And we want to describe how an equilibrium conditions are represented in a phase diagram. So a phase diagram is something that we're going to be looking at in class as well as in this lecture, and it deals with temperature and pressure. So as I mentioned on the introduction slide, sublimation is the change of a substance from a solid directly to a vapor without passing through the liquid state. So some examples of things that undergo sublimation include iodine, dry ice, which we'll see in class, mothballs, so as you're putting your winter sweaters away, maybe your grandparents use mothballs, and then solid air fresheners. These could be like those toilet bowl cleaners that we talked about and smelled in class, as well as like those like reuse it things that you might stick inside your like laundry hamper at home, or maybe a smelly closet or something like that. Also, if you have like a sports bag and you have like those little plastic balls that smell nice, they look like a little golf ball or a little basketball you throw in your shoes to make them not stinky, that's an example of a solid air freshener. Okay, so besides sublimation being really awesome and helping us make root beer, it is also useful in other situations such as freeze-drying foods. So if you had coffee there, you'd want to definitely go from the solid phase to the gas phase without making it kind of like all sticky and goopy, that coffee. And what's really awesome here is they talk about removing the water vapor by using a vacuum pump. So going from that solid to that gas phase, you're not making your substance wet, which is nice and yucky, and then you're able to remove that vapor with that pump. And we also like sublimation in chemistry because it helps us separate substances. So one of the things that we talked about in our previous lectures was that boiling point can change at different elevations because of the pressure differences. So we use these phase changes to help show when a substance will boil, when it will freeze, and more formally, the relationship among the solid, liquid, and vapor states, or these phases, when we're talking about in a sealed container, are represented when we look at a phase diagram. So the phase diagram gives the temperature and pressure at which a substance exists as a solid, liquid, gas, and remember we can use this term vapor for gases. So on the next slide, we're going to go ahead and look at one of these phase diagrams, but when we get there, you're going to see three different colored regions, and each region represents a pure phase. So again, a solid, liquid, or gas. There's a line between each of these colored areas, and this is where both phases exist in equilibrium. And there's a special point on the phase diagram that I want you guys to pay attention to. It's called the triple point, and this is where all three curves meet and the conditions at which all three phases of matter exist in equilibrium. So I just think that's pretty cool that there is a specific temperature and pressure at which you could actually find all three states of matter. So here's what a phase diagram looks like. So a couple of things that I want you to pay attention to is notice down here on the x-axis we've got temperature, so our temperature is increasing this way. Over here we've got pressure, and it's measured in kPa's, or those kilopascals that we mentioned in class. So we have these colored regions now, so we can see that this orange area is the solid, this blue area is the liquid, and the green is the gas. And hopefully this kind of makes sense. At a colder temperature, yeah, this is where we'd have our solids. At a hotter temperature, this is where we'd have our gases, okay? But then let's talk about what's going on with the pressure here. Remember, at high pressure, those particles are going to be packed closely together, where if they're at low pressure, they're going to be far apart. So that's why you can have high temperature over here, but maybe you're still in the liquid phase. Well, that's because you're also at high pressure, and that's because even though we're at high temperature, we still have a lot of force pressing those particles together. A couple of other things to note on here is you can kind of see the phase change names here. So we've got melting and freezing between solid and liquid, vaporization and condensation between liquid and gas, sublimation and deposition, so this is the word that we actually don't get that often. That's where we're going from the gas phase straight to the solid phase. And then here's that triple point that I mentioned, and it's the point at which all three states of matter exist, or the pressure and temperature at which all three states of matter exist. Then we actually have this thing out here called the critical point, which we'll see, and it's like where it really can't exist anymore as a liquid, and so it's going to be just a gas at that point. So here's just a graphic of some questions that we might see, and sorry that there's already all these circles and stuff like that on there, but let's go ahead and let's look at this data and make sure that, or let's look at this graph and these questions and make sure that we can answer them. So question A here says, at the triple point of water, what is the value of the temperature and pressure? So again, this is a little different phase diagram than we looked before, but clearly you can see solid, liquid, and gas. So we want to see where they're all meeting. They're meeting down here at this triple point. So we would say that it has a temperature of 0.016 and it has a pressure of 0.61. So that's where we'll see all three states of water. So over here in inferring, what state of matter are present at the triple point? Well, hopefully you're saying all three states are present because we just talked about that. And you can see that the dot is touching all three states. And now for C, analyzing the data, assuming standard pressure, at what temperature is there an equilibrium between water, vapor, and liquid water? So this is kind of a big question. So it's talking about standard pressure. So remember, standard pressure, like at sea level, would be that 101.3 kilopascals or 1 atmosphere. But in this graph, we can see that we're working in kilopascals, and they already have a little dotted line here for us, showing us that standard pressure. And now it's asking for an equilibrium, or like where that line exists between water vapor and liquid water. So remember, vapor means gas. So here is this line that exists between the vapor and the liquid. And so we're just going to come on over, follow our little dotted line, and kaboom! That is the line, the dot there, where it exists. And we can see that this is called the normal boiling point. And that makes sense if you're going from the gas phase to, my bad. If you're going from the liquid phase to the gas phase, we would call that boiling, so that is the temperature normally at which water would boil, and you can see that that is 100 degrees, and so we know that. The second part of the question here says between the liquid water and ice. So same thing, if you're at standard pressure, here's our little dot, we're going to follow it over here between these two, and you guys can see that this is called the melting point. And so we know that ice melts at 0 degrees, or freezes at 0 degrees is what you might be most likely thinking of. So a key point when we're talking about these phase diagrams is that the changes in melting point and boiling point can be determined with changes in external pressure, which we've talked about before, but we like the graph because it's easier to find that way. And just a quick review question, what are the variables plotted on the phase diagram? I'm hoping you guys are going to say that it's going to be temperature and pressure. And the phase diagram is not the only diagram that we're going to look at during our lecture in the next couple days. We're also going to be looking at something called the heating curve. So remember, for the test, we want to worry about phase diagrams and heating curves. And I hope that was helpful. Thanks.